Okay, welcome to Students for Students. For more videos, please go to our website, which is www.s4sonline.org, and you can check that out. Okay, today I'm going to go over how to go from 2 points into turning that into an equation, and then turning that or being able to sketch that on a Cartesian plane. Okay, so let's just start with 2 points now. Okay, so let's start with the point 2 comma 4, and our other point is 8 comma 16. Just making this fairly simple. Okay, so we've got these 2 points. So how do we go about turning that into an equation? Well, the first step is to remember that the m, the gradient, is equal to the rise over the run. And also a really handy one to remember is that that's the same as y2 minus y1 over x2 minus x1. Okay? Please excuse my handwriting. Okay, and so we can label these points up here. So this will be our x1, this will be our y1. This will be our x2. This will be our y2. Okay? And basically we can just put all those in and we can find our gradient. The second step will be to turn that into an equation. So we can use this one. Y minus y1 equals mx minus x1. Okay? And so our y1 will be over here, and that'll come from up there, and that'll go into there. And our x1 will come over into here, and the gradient will work out from here. Okay, so we can put those 3 things in, the 3 unknowns, the y1, the m, and the x1, and then we'll be able to simplify and turn that into an equation. Okay, so let's go ahead and do that now. So it's just a matter of plugging everything in from this step. So y2 is that's 16 minus y1, which is 4. Over x2, which is 8, minus x1, which is 2. Okay. 16 minus 4 is 12. 8 minus 2 is 6. So our gradient is just 2 when we simplify that. Okay, so now we have our gradient here. We can move on to step 2. So let's do that. So y minus y1. So I'm getting that from up here. That's 4. Okay. Equals m. I know that is 2. And x, well, that just stays x. And x1, that's 2. Okay. So from there, that's pretty much it. All we have to do is simplify this expression down here. Okay. So let's just get rid of that. Okay. So plus 4 to both sides, plus 4. Okay, that's going to cancel. So we just get y equals, here we expand, 2x and minus 4. And then we've got the plus 4 here. Okay, so they cancel, and we get left with y equals 2x. which is sort of a special line here because we have no y-intercept. usually we'll get things in this form: y equals mx plus c. Okay? But in this case, the c doesn't actually exist. It's like plus 0, if you like. There is no c. So this is sort of a special sort of case in that way. So let's look at plotting that. What would that look like? Okay, so draw our Cartesian plane. Whatever. Okay, so we'll need to know the x-intercept and the y-intercept. Now, like I mentioned, this is a special case where the y-intercept is 0, alright? Because we've got a plus 0 on the end, if you like. Okay, and c is our y-intercept. Okay, so the y-intercept is 0. The x-intercept is also 0. So let's just think about that. If we put the x-intercept occurs when the y-intercept is 0. So if this is 0 here, right, x has to be 0 too. So this is a special line that goes through the origin like that. That's that line, y equals 2x. Okay, so how could we show that this line is different from a line, for example, that is y equals 3x or 4x, etc.? What we could do is just put in a point that is 1. So when x is 1, so this is my x, this is my y. When x is 1, so we sub that in, 1 times 2 is 2. So y will be 2. Or we could even say that the gradient is 2. Okay, so there it's clear that this is y equals 2x, and we've put in a little scale there, if you like. Alright, so we've been through how to go from the point into the equation, and then how to go from the equation to sketching it on the Cartesian plane. This has been Students. Please check out our website for more videos.